In lecture 4, we discussed the vector and modulus in complex analysis. Here is two vector. The first one is z equal to x plus iota y. We represent x plus iota y by this vector, and both the x and y component are positive, so the vector lies in the first quadrant. And now the second vector is minus 2 plus iota, and this one is the minus 2 plus iota. This one is because the x axis is minus 2 x and the y axis is 1, because with iota is 1 here, and these two numbers are represented in this plane, and we can say this one is a vector and this one is another vector. Our problem is to how we add these vector, and that one is simple. We add z1 and z2 by this way. Now the lecture is focused on the modular, how we take the modular of a complex number. We take the modular of a complex number by the same manner as we take in real system. That one is z equal to x plus iota y. We take the square of x plus y square under root, and this one is called the modular of a complex number. This formula we use and get the result. Now we are on example 1. In this example, minus 3 plus 2 iota, and the modular is here. We want to take the mod of this number. First of all, we take the square of minus 3, that one is 9, here is 9, and this one we can't be include iota. Just mention that is this one is the imaginary part, and we don't use the iota. And after that we take the square of 2, and the square of 2 is 4. Adding both number 9 and 4, we get the result 13 under root. This is the way we take the modular. And in same manner we want to take the modular of this number 1 plus 4 iota. We use the same formula. That one is 1 square is 1, and 4 square is 16, and adding both of them and taking their under root, we get the under root 17. Now we discuss some basic properties of complex number and modulus in modular form. Now this one is if we write z1 minus z2, and we can also be put this one in this form. Now in next, here is the example 2. In example 2, we want to know what is this one. What is this? This modular represent the circle. How we know this is a circle? When we simplify this one by taking their modular, and their the result is in a circular form, because you people know the value of z is x plus iota y. We substitute x plus iota y, and minus 1 plus 3 iota, and they taking their modulus. After we get and we find that this one is a circle, and their center is 1 minus 3, and radius is 2. Now if you people can't understand this example, then we will discuss this example in next lecture by doing manually, and hope so at that time you understand how we represent and how we understand any given modular in a complex number, and they represent what the shape. In next one we are focus here. The modulus of a square is the real part square and the imaginary part square, and this one is and the modulus also satisfy this property. The real of z the real part of the complex number is less than equal to the real part of the z and their modulo, and it also be equal to the less than equal to mod of z. And this one is a very important property, and this property hold for both real and imaginary part, both of them. Now we are here, this one is the z1 plus z2. This one is triangular inequality. In we can say this one the z1, when we apply the modulus 1 by 1, then we can say this one is less than equal to. This is important property you people keep in your mind. In the second way, if we use this one is this form, if z1 plus z2, and by using the minus sign and another modulo, then this is greater than this value. By these we above property are the, by using the 5 we can write this one in this form, and we get the property 6. In same way this one is also greater than equal to this, and now this is the another property, and this one is conclusion of the result, that is the simply z1 and z2 conjugate is less than equal to separate of the conjugate of their conjugate in case of plus, and if and greater than equal to in case of the minus. This one is their example, and we will discuss practically and manually the exercise on board, and in next lecture, so we can find all of these example and we may understand. This one is the general up to nth term if involved, and we can use the triangular inequality for nth complex number and the modulus. Okay viewer, we will meet in next lecture with this exercise by doing manually on board, and hope so all of that things that providing confusion for you may be helpful, and hope so after take the next lecture you people able to solve all of the problem about modulus.